Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. You know, I just wanted to take a quick second before starting today's stream to point out that the folks who provide the forums for Handmade Hero, which is Handmade Network, who actually provide the forums for a lot of projects that are hand-coded. They have finally added something that I know that they have been wanting to add for a while, but I think they wanted to make sure that they had a good procedure in place for handling such things before they opened it up. But they decided to open up their project submissions for anyone who was interested in having a project hosted there. And you can see that if you go here to handmade.network/projects, or you can just go to handmade.network and click on this projects button. And that page lists all the projects that there are, but previously, if you wanted to be part of their project hosting, you had to email someone involved with the site and ask them to add you, because they didn't, again, have it set up yet for public submission. But they've finished all the stuff they wanted to do for public submission, so now you can do a really handy, quick submission process. If you haven't registered for the site yet, which of course on this browser I haven't, I am registered on the site because there's our project right here. If you haven't, you just register first to make a username, and you might already have one of those because you may participate in the forums here. But if you don't have one, you just register up here, and then this register or login bit will change to a submission button you can click, and then you can send the information about your project, and they will take a look. So yeah, if you're interested in doing a handmade project, and by handmade project, I mean, I think one of the interesting things about handmade project is, certainly I never attempted to define what handmade project meant, and I don't know that anyone really knows what it means because it wasn't supposed to be a name for anything. It was just the name of this particular series. And now it carries a lot of connotations, I suppose, with it that are different from person to person. But in general, I think it just kind of means if you are someone who's interested in programming and learning about programming and doing programming in a dedicated way, where you actually care about the results and you care about what's going on, I feel like that probably slots in here. And if you look at the kind of projects that are in here, they're pretty varied. They're not specific to games or anything. So for example, 4Coder is the editor we use on stream, and that was handmade by Alan Webster. Handmade Hero obviously is the show you're watching. Motionbox is a new browser, oddly enough, which is kind of totally not game related, but it's designed to just browse videos. Like that's all it does is browse videos. So it's kind of like meant to be sort of like a new way of thinking about television, right? And a lot of people really like this. I've heard a lot of positive things about it. So again, completely unrelated to video games or the original product in any way, but it's just like part of the sort of idea that, building things and caring about them is good. And then there's Papaya, which is a image editor, right? Like a painting program. There's a game engine kind of thing, like not a game engine necessarily meant for like shipping commercial games, but a game engine that's made so that you can learn how to program video games. It's like a teaching engine, if you will. Obviously, Sean Barrett's fabulous collection of libraries that a lot of people already use, they're now hosted on here. The list kind of goes on here, and they've built up a pretty impressive list. There's even people who are working on new debugging tools, and that's going to be kind of awesome because I've always wanted to switch away from the debugging tools that I have currently. I don't love them. And so, much like we switched to 4Coder because I really didn't love Emacs, and I'm much happier on 4Coder, I think maybe, the day might come when we get to switch from Visual Studio on stream, which I've never really been a big fan of using for debugging, to one of the debuggers that people are building here, which would probably be more focused towards the kind of debugging that we do, right? Visual Studio is geared towards a very broad audience of people that doesn't really necessarily have even program in C++, right? And so a lot of times the focus on that debugger is elsewhere. And so it might be that one of the debuggers made here will focus more on the kinds of stuff that we do. So there's all sorts of stuff here. Of course, Milton is the paint program we use on stream as well. So that got written under the Handmade Network banner as well. So there's just a lot of great projects on here, and even if you're not thinking of starting a project, you should probably check out the projects that are on here, because a lot of them also provide source code, so you can learn from them as well. And if a lot of them also accept either donations or are commercial, so you can purchase them. So if it's a project that you want to support, that would be a great thing to do, because obviously the folks who are building these things could, they've got to eat too. So yeah, all this stuff is pretty cool. I would definitely recommend checking it out. And if you do have a project that you think you would like to be part of the community that they're working on at Handmade Network and the sort of stuff that they're doing, that's the news, right? The submit a project button is up, and they are ready to start looking at folks who have projects who might want to host on here. So give that a shot. Again, Handmade Network /projects. And yeah, the folks on the chat, Abner Coimbray and Andrew Chronister and Jerome, let's see, I think it's just Abner Coimbray for usernames, Chronal Dragon and Kalimian on the chat, I believe do most of the site work. So if you have any questions about that, and or you have any trouble submitting your project, because again, this is a brand new feature, check them out on chat. They're oftentimes on during Handmade Hero, so you can find them in the Twitch chat or on the Handmade IRC. Or you can also, if you registered a username, you can go to the forums here, and there's a site feedback. You just, from the Handmade Network main site, you can just click on this forums button, and that forums button will bring you to like a place where you can post questions, or if you're having trouble with the site, or there's just something about the site that didn't work the way you thought, that's a good place to let them know so they can be aware of it. As I'm sure you're aware, with web development, a lot of times things are different on different browsers, or different things happen that are confusing, and they might not know about the issue that you're seeing, or they may not be aware that there's some problem with a specific configuration or whatever you're doing. So if you're having any trouble, that's the place to go as well. And again, if for some reason you can't even register because of something in your area or whatever is happening, check them out on chat, and they can help you out. All right, so that's about it. We are ready to get started here. I don't know why this isn't showing. I guess because it didn't get reopened. Yesterday I pushed the Clang compatibility. Well, push is probably the wrong word. I did the work on the Clang compatibility stuff, but I don't know why it's not on here, because I closed it, but I thought it got reopened because some folks did do the testing on it, and there was one other thing that we needed to fix when they tried to compile it. Now, I don't know why that's not on here. That's a good question, because these are sorted by date, are they not? So it should have been right up here, but I don't actually see it. Now, maybe it's because it didn't get recorded in here for some reason. I'm not sure, or maybe the notifications page would tell me. Here we go. So why was that not? I don't know. Anyway, all I can say is we found it. We'll just consider that a victory there, a little minor GitHub victory, and we'll just go with that. So, okay, here was the actual thing I wanted to talk about. So this is the fellow who actually, I believe, continues to maintain an SDL port in the GitHub as well, for Handmade Hero. So he compiles it on Clang all the time, and Martins and him were the two people who basically gave me all of the information I needed in order to fix the build under Clang. So he went ahead and tested it, and apparently the problem now is confined to just the time function macro, and it has to do with the fact that the char, the function is declared as const, the function string. So we need to cast away the const. so that we don't have a compiler error there when we pass it to the timed block function. But the other thing is, I guess we weren't properly passing the counter or something. So I got to go take a look at that as well. That may have just been a mistake on my part. I'm not sure why that didn't fail in our build, but there's probably a good reason for it. So we'll take a look at that as well. It looks like there was some problem with GCC where the macro expansion leaves a comma incorrectly, which I'm not sure why, because I thought that double paste thing was supposed to be the way that that gets fixed. But I don't even know if that double paste thing is standardized or not. That may have just been a convention for not having the comma, or I don't really know. But yeah, that is just a generic thing that I use when I end macros in general to make sure that they can pass through more information if necessary. And that just, to give some perspective on that, the reason I do that is because then if the underlying function that the macro calls adds new optional parameters at the end, it'll still work without having to change the macro. So I typically just do it that way. But as Kim's pointing out here, we don't actually use that. We have never needed to pass additional arguments. So at least for the time being, and probably for the foreseeable future, because timed function, I never really envisioned it taking more parameters anyway. This is just, like I said, more of a thing that I just do in general when I make macros. So there's really no reason we can't eliminate it. So the fact that there's that extra spurious comma getting inserted by GCC, we can work around that in exactly the way that Kim is suggesting here. Basically, by removing that args, VA args entirely, then we won't have the problem. So let's just go ahead and do that again. It'll only take a few minutes to even do. It's a very, very simple change. We did all the sort of actual work that it was necessary for this yesterday, so it's pretty easy. If I just go and compile the project here, just to make sure everything's set up properly, if I jump back to the GitHub and look here, you can see it's just the time function thing. We know that that's in debug interface, and so we'll just jump down to it. Here's time function. And if you take a look at what's going on in time function, again, you can see that it's just really something that's getting passed down to the timed block, right? You can see the timed block here. And here is that timed block function. You can see the hit count in it, right, which is there, which is to record a single hit. And as you can see, we're not using that anymore. And so this is what I was saying about, we don't really need that aspect of the macro anymore. So we can just get rid of it for now. If we find that we need it again, well, we'll have to think about that and deal with it when the time comes, right? For now, we might as well maintain GCC compatibility because that's the only thing stopping us from getting that. So if we take this out of the timed function, right, and you can see us passing this information here, when we call the timed block, we're supposed to pass a GUID, a name, and a number. Now, I don't know why we were able to not pass that number here. That's a really good question, and I guess it's just because the number isn't getting used, right? You can kind of see that the number just isn't getting used. So it looks like that number was actually getting passed as the hit count, which was just getting ignored. So I think this is just legacy code anyway. So I suspect what we can probably do is just say, like, OK, timed block really just takes a GUID and a name, and that's all it does, right? The counter is not necessary at all. Neither are the variable arguments, because all they're going to do is end up getting past the time block, which we already know we don't need, right? So if you take a look at what's going on here, we could just say, like, OK, if we just want to leave this as simple as possible, which we might as well do at the moment, we can always make it more complicated later, right? No programmer ever was like, oh, I can't make that more complicated for you. If we just go ahead and get rid of sort of the vestigial remains there, then we're left with something that will probably be able to compile properly on all the platforms, right? And so I think what we probably want to do is say, well, OK, since name just gets replicated multiple times here, probably when we do timed block, we just pass a name and then we replicate it twice. All the other aspects that we use, we're going to go ahead and use sort of the GUID expansion version of them here. And then when we call a timed function by itself, we're just going to pass function and function as the name, right? And you could imagine us just calling timed block here with because with function as the only parameter, but I'm not going to bother doing that because, again, since we're trying to get this to compile on multiple compilers and we have testing of a current macro set, I don't want to like poke the hornet's nest there any more than is absolutely necessary. So I feel like just trimming that out, we should be in better shape now. You know, here's everything running, I believe, properly. And if I go to the profile, you can kind of see that our names are still good, right? There's nothing weird happening there with our timed function blocks. These are all timed functions. So it looks like we're all good, right? Everything seems fine there, and so I think that's a change that we can keep. Now, like I said, I don't understand why this didn't show up there, but it looks like because it's not, it looks like Kim didn't reopen the issue. It might be because he can't, I don't know what the rules are on GitHub. It may be that I accidentally closed it in a way that, it may be that only I have the authority because it's my project to reopen the issue. I'm not sure. But anyway, I'll just write it here so he could see it. And then I do get email notifications when people reply to these issue streams. And so in that way, right, I can know if there was an additional problem with it, even though it's not listed as an open issue anymore. Did I spell that wrong? It's vestigial, isn't it? Yes, it is. So now we've at least tried to make this stuff work here. And hopefully that will now bring us into full compliance with all the compilers that people use, Clang, GCC, and MSVC. No way to know without testing. We will certainly find out, and we will let the folks who use Clang on a regular basis let us know if everything is now working correctly for them or whether there are still issues out there. Okay. So today, I guess I'm not exactly sure what we want to do today. I was thinking that probably what I'd do is just kind of play with that camera code a little bit and just maybe sort of like get that stuff to a state that I'm happy with. And then that way next week we can start on 3D fresh. So from the start of the episode, we'll just do that. And you can kind of see that we've got some weirdnesses now and stuff that we would probably want to improve and address. So there's a couple of different things we might want to do here, right? So let's just talk about those for a second, and then we'll sort of talk about what we can do with them or about them. So at the end of yesterday's stream, we had gotten it to the point where we now have all of these sort of rooms that can be different sizes, right? So we used to have it so that the rooms were always the same size, and now we have it so that the rooms are different sizes, right? And you can sort of see that that's happening both horizontally and vertically. Like we have rooms that are wider, rooms that are narrower, rooms that are taller, rooms that are shorter, because it's just getting a random variable there and making the room whatever that random size is. And the rooms are just stacked against each other with a dual row of trees in between them. That's all we made. You know, we don't have really any world generation code right now. We just have really basic stuff. So if you take a look at what's going on there, you can see that basically everything's working fine with the camera in terms of picking out which room we're in, and everything's working fine with the world gen to a certain extent there, and that's all fine. But also, I would point out, you can kind of see where all our time is going here. Remember, our get closest traversable function is, of course, the function where we don't have any acceleration. It's n squared. So the number of entities on the screen, it just goes up and up and up, right? And is currently the very piggiest of piggy. So we kind of have a nice we have a nice profile there for our future optimization, because that's a function we can very easily flatten down to very little cost. Anyway, but that's beside the point. So if you take a look at what's going on here, everything's working fine in terms of what we wrote, but obviously it's not very good in terms of anything you would really want to ship in terms of a good player experience. The reason for that is like you take a look in here, and this room is too big, like for the player to even see what's going on in the room. And we don't make any attempt to like zoom out to see the whole room. We also don't pan the camera. So if the room is too large, then we get in these weird situations where like the camera just does really strange things. I mean, I guess they're not strange per se, but they're not helpful. Like if you were a player playing this game, like you wouldn't be happy with what was happening here in terms of how the camera was moving around. And we've never really done any real camera code here. And so what I think we probably want to do today is just go in and finish up working on the camera code. Like, okay, you can see all that is kind of nuts what was happening there, right? We're going to go in here and just make something that's a little more sane for how we're doing our camera control. And that way, when we have something more sane for doing our camera control, we can just go ahead and excuse me. We can just go ahead and have our gameplay systems dictate what the camera is supposed to do, and then it will be relatively straightforward for those systems to pick what they want. And so, for example, you could imagine a circumstance where we want to sort of zoom the camera in and out to control how a particular region works. So, for example, let's say that we turned on the debug camera here, right? Let's see. There we go. So one thing that we might want to do, let's say we had a really tiny room, right? Let's say the room was only this big. Then we might want to like zoom in to that room and sort of have it so that we were all, close in. Maybe that's a little too close, but all close in on the room because it's supposed to feel like we're just focusing on that room, right? But then if a room is too large, maybe a room's really big like this, we may not feel like gameplay-wise the right thing to do is to zoom out all the way to the full scope of the room because maybe it just gets too tiny and too difficult to play. I don't know. We don't know those answers ahead of time. So the important thing to do here, I think, is just to make it so that the camera system can do whatever we want it to do. And then we can have it so that as we're doing gameplay, we can sort of make decisions on a case-by-case basis. So maybe we want, you go in to talk to the shopkeeper or something like this. I'm not saying that there's a shopkeeper or anything, but, you can imagine in a game where you're going to go buy something at the store. If you imagine something like that happening, and maybe that room is pretty tiny, maybe we want to zoom in on that. And that's the grammar for that. So you zoom in, zoom out on rooms of a certain size. But maybe once rooms get to a size that's larger, that's too large, that exceeds some threshold that we set, maybe then the camera just pans around to follow the player in the room as necessary, right? It's really hard to say which of those we're going to want. So like I said, I think we just want to kind of focus on making a camera system that will allow us to do whichever of those we want to do. Okay. So basically, we have a lot of easy options here in terms of actually setting the camera, right? And so, for example, just to illustrate how the system is currently working, especially because we bounce around a lot here, and especially for beginners, it's probably hard to keep all the what's going on in all the different pieces of code and how they work in your head, because we bounce around and we change them and we talk about different ones at different times, which is again very in keeping with how game development actually works. Typically you have to bring up systems kind of together, and you're not just focusing on doing one thing, finishing it completely, and then moving on to the next. Sometimes that's the right answer, but other times when you're trying to do architecture, the answer is to kind of be more broad. But that can be very daunting for people who haven't done a lot of these systems, because they're trying to learn how to do some of the programming in the system, and then there's also all this other stuff going on, and we're moving around, and that can be pretty challenging when you're sort of first starting out. And so just to kind of reinforce what's going on here, when we go into when we start playing the game, right, and we've got the camera can actually be set at any distance above the playfield already, right? Our debug camera isn't the only way that can happen. There's a camera offset variable, and you can see that here. So here's the game camera, right, that we keep. It's basically just a struct that has some information. It says which entity it's following. It says what its two positions were, the one from the last frame, the one from this frame. And it's got an offset. And the offset is basically how far away from the central, like, tiled chunk position, which is this world position here, right, the camera is. And that's a three-dimensional variable. So not only can it displace laterally and vertically in the room, or in the world, basically, but it can also displace up and down. And so if we want the camera to be back further, if we want it to be up higher, all we would have to do is just set that variable to be up, right? Set that z value to be a greater value, and we would zoom out. Or at least that's how it's supposed to work, right? So what we could say, and let's just, again, to sort of illustrate the example, let's just say that, we have these sort of room entity sorts of things here. If we wanted to, we could introduce a variable that was like, hey, let's say there's a thing called camera height, right? Let's just say that's what there is. And what we're going to do is whenever we go into update and render worlds, we're going to call, remember how this works, we call simulate, and then before we're done, and we call update and render particle systems, before we're done, we call a function called update camera for entity movement, which sort of decides where it's going to move the camera to follow the entity that the camera is ostensibly supposed to be following, right? So, given that that's what we want to do, what I can do is say inside the code for that function, which is update camera for entity movement, what I would say is in this function, I think we can just read out, because we know which entity is the entity defining the room that we're in, we can just read out of there what the camera height should be and then set the camera height to that. And so I just want to show how that will pop the heights in and out as we move from room to room, right? And again, this isn't going to be a good thing yet. It's not going to look nice, but I'm just trying to illustrate how we would go about constructing that that beginning of the process. So just knowing what the height should be, right? So here's, well, I guess we have in room, which is getting set. So all I really need to do in here is say, OK, here's the camera offset, right? You can see there that the camera offset is getting set. And you can see here it's getting set to a bunch of random stuff based on what the entity situation is. So then what I can say is, oh, in addition to that, right, I can set the camera height. I can offset whatever we were going to use for our camera height by a greater height based on whatever the room we're in says the camera height should be, right? And so most rooms will maybe just have that set at 0, perhaps, and then we've got kind of that exact situation, right? Here's the camera height for this room, whatever, okay? But what we can do now is say, well, okay, now when we're actually creating these rooms, so when we say add standard room, right, you can see here, you can go in and say, well, when we want to create one of these things, and you remember we added sort of a brain ID for these rooms. Where is my add standard room? There it is. You can see when we added the room entity itself, right, which is right here, we had the opportunity to set something for it if we wanted to right here when it's created, and that will get remembered so later we can look at it. So what we could do is say, well, let's just see what the maximum width and height settings are for this room and maybe set the height based on that, right? So here's our radius x and radius y. What I could do is say, well, let's make the camera height be proportional to their difference from the default or something like that, right? So what I can do is say, all right, let's suppose that we had a diff value here or something like that. And that was going to be like a clamped value, let's say, where I'm going to say, all right, it's got to be, it can't be less than 0, but it's got to be something greater than 0, where I take these two values here, radius x and radius y, right? I'll say radius x minus its default, which is 8 for now. And then I'll say take the maximum of both of these, right, where I just say, okay, I take the maximum of the two radii differences from their default. I don't want a lower value ever. So like if it's a smaller room, I'm not going to zoom closer in at the moment. I'm only going to talk about zooming out. I'm going to take that difference and I'm going to make that difference be the camera height at the moment. So for every tile outward we go, I'm going to move 1 unit upward for the camera, right? At least that's the theory. And so now you can see it's already sort of working to a certain extent. Now that we're in this room, you can see that we get a zoom out that features the entire room. Here we go. I think we're doing something wrong with our collision detection there because there shouldn't be a middle area between the rooms, but we're going to get to that in a second. And so now, we're zoomed out a little bit more so we can see the whole room at once. And there you could see that it was a discrete jump in the zoom level, right? Did you see that? Because again, we're not interpolating that value yet. We're just jumping it. So whenever we move from room to room, we definitely have that jump, right? But now you can sort of see that we fit the rooms much more nicely. So, we get into situations where we have a longer room or a narrower room, and we adjust, okay? And that's kind of nice because now for game design purposes, if we want to, right, we can basically make the playfield be whatever we want it to be. Now what you'll notice here, this is the first time that's happened so far when we've walked through it, you can kind of see that when we went into this room here, the camera, that value is a very rough value. Like that was just an ad hoc value that I picked. And so if we actually wanted to see the whole room, right, it would have looked like this. But that's actually what we got, right? So it's not really looking at the whole room the way that we would want it to look at the whole room. And so, oh, and I just remembered why we're not doing collision detection properly. It's because we don't create collision boundaries for the room yet. So we already know why that is happening. I already knew that yesterday, but forgot it. Anyway. So what's the reason for that, right? Well, the reason for that, and we'll sort of talk about this on the whiteboard, I think is probably the most important, the most appropriate way. I feel like we have to. There we go. One of these days, I'm going to get a graphics card that's less than 10 years old so I can actually run Milton on it reliably. I'm still using I'm using an old version of Milton because I don't have a graphics card that really it's a 6-year-old graphics card in this machine. It's old. Anyway, so room camera fitting. So let's just talk about this problem briefly, and I don't know that we want to bother solving it really at this point, but at least so you can be aware of what the problem actually is. And so, we probably would solve it at some point. I don't know. I guess it depends on whether we decide that we're going to use this in this way or not. So what ends up happening with camera fitting, right, is you can imagine we've got, if you've been following Handmade Hero, you know exactly how this sort of stuff works. We've got a camera, and the camera is looking down on the world, right? This is our camera. And this is Z, right? And we've got this sort of plane here that we're looking down on, right? And this is the world, so, the world is down here. And the world is in these Z slices, right? Because it's a 2D game. But in some sense, we think of it as 3D. So we actually do consider things having volume and whatever. But when we view it, we're sort of viewing a slices stacked on top of each other. So what ends up happening is these slices have always been the same size. And so from the camera's perspective, if we were to look at it, right? If this is a room, what we've been typically doing is we've just been hard coding whatever the camera's distance up was, right? Here's that viewing area, right? So this rectangle here maps to this rectangle here, right? This is top down. We've just been moving the camera back manually to see however much of the room we wanted to see. So if we wanted to sort of make, I just kind of tuned it to a value that I thought looked appropriate, and that's what we left it as. And that's a perfectly valid thing to do, and that's how you want to do that. But we introduce a problem when we then say we don't know how big the room is, right? Because if the room is only this big, then we would pick a very different value for how far the camera zooms out, because as the camera moves closer, this viewing area gets smaller, and as the camera moves upward, that viewing area gets larger, right? So if the room is bigger, we want to move the camera further back, and if the room is smaller, we want to move the camera down. But the key fact here is we don't know how much, right? We have no notion of how much to move the camera. So in the current system, I just picked an ad hoc value of 1 meter, right, per tile in radius, right? That's what I did. So I basically said, all right, here's the standard room size. Okay, its radius is at the moment, its radii at the moment, is 8 tiles this way and 4 tiles this way. So all I did was say, okay, for every room, if you go over 8 tiles, right? So if you get more than 8 tiles out, for every tile you go out, add a meter to the height of the camera. So if you were going to be out here, you would add 1 meter to the height of the camera. Similarly, for every one you go out here, add 1 meter to the height of the camera. Now, since these two things don't add together, meaning if I'm already moving out this far, I don't need to also move out again to capture this, because movement of the camera upwards expands the horizontal and the vertical range. So what that means is that I just take the maximum. I just said whichever one of these two, right, is going to be greater, use that difference. And by the way, if you go inside here, don't bother, because we don't get closer in on ones that are lower at the moment. We have like sort of a minimum zoom range, right? So the problem here is that's a totally ad hoc thing, right? And don't get me wrong, you can absolutely ship a game with ad hoc stuff like that. It happens all the time. Hand-tuned constants, when they work, and you're done, right? So you don't need to belabor technical solutions to problems you don't actually have. And so if this is good enough for you, then you should just use it. But we may get into situations where it's not good enough, right? And so it begs the question, what could we do that would be better? Well, as you know, it's just math, right? It's not like we couldn't figure out how big the camera's viewing area is when you get down to this particular distance from the camera, right? Because if we were to look at this again from the side, let's say, so this is perfectly side on. Here's the viewing axis of the camera, right? Viewing side on. And here are like sheets. And you can imagine, like, as we go down further in the camera, like maybe this is like 3 meters away, and maybe this is 5 meters away, and maybe this is 7, and that looks like a little more. So maybe that's 10. I don't know. So whatever distance away we are here, each time we go down, we're widening that area, right? Now, for any given room, we know both things we would need to know to reverse our calculations, right? We know how big the room is, okay? Because we know how big a tile is, and we know that if we make a thing that's like 12 tiles by 8 tiles, let's say, we know how big that actually is in meters, right? So we know, if we were looking at one of these things, we know like, oh, okay, if this is how far away it is from the camera, and we know how big the room is, maybe it occupies this much space, right? We could easily compute both of, we know this value. We could easily compute this value and say, well, we know the camera is viewing this much distance. We know we want to view this much distance. So there's a gap here, and it's like, is that gap, we probably would have some value for the gap. How much of a gap do we want or are willing to have? And if that gap is too big or too small, maybe the room just overblows the size entirely, so we know it's totally too small because there's no gap at all. We can solve for the distance we would have to move the camera, like how far out it has to be in order to be that size, right? And doing this is not that hard because it's all just very simple high school geometry, right? It's just a case of, well, trigonometry, sorry, I think is the correct categorization here. It's just a case of similar triangles, right? We have a situation where we've got the camera here. It's looking down here. We know we've got, and you could imagine there's just the other side of of it here, but we're only going to look at the right triangle part of it because we know that it's just 2x is the distance here. So we know that if we have a ratio that can produce, we know how to compute these triangles, which we do know how to do. If you go back to when we did projection, we'll go over it again. If we know how to compute one of these triangles for some distance here, right? So we know for the distance away from the camera, we know how long this leg of the triangle is, right? We know this is basically the viewing width, right? It's a half the viewing width, right? Let's say. So if we know how to compute half the viewing width from the distance, then we know how to compute the complete viewing width the distance. So if you give us some other viewing width, right, we know that it's just going to be a straight ratio of that one that we want, right, which would be half the viewing width we wanted, which would be here. This is like our desired width, right, over 2. So half the desired width versus this thing we don't know, which is the desired distance, right? Desired distance, I guess. These are some bad, probably have too many D's here. Let me try that one more time. Let's try that one more time. So we've got the width of the view and the width of the desired versus the desired view and the desired distance, right? So we know this and this, right, are a ratio that we already know because we set up the camera, so we know how to generate these triangles, right? We already know what these are. So since we're prescribing one of these, all we have to do is solve for one of these, right? Because these things set up an obvious ratio. Since they are similar triangles, we can easily just say that dv over wv equals dd over wd. It's just a similar triangle ratio. The sides have to be in ratio to each other. So solving for one of these is as simple as multiplying out, right? So you just have dv over wv times your wd equals your dd, right? It's just, like I said, really simple high school math, nothing to it. So as long as we know that ratio, as long as we know how to compute that ratio for similar triangles for our camera, which we had to do to make the projection equations in the first place, then we know how to produce that. And again, we have to do this, though, keep in mind that it has to be done for both of our axes. If we were to look at this top down again, right? So here's the camera. It's looking down on things. We have to know this for both of our axes. So we have to know it for our viewing width and for our viewing height. So we're actually going to have two of these equations where we end up with two different distances. One is the distance where we would exactly fit, that the camera would have to be at to exactly fit the width that we asked for, and one would be to exactly fit the height that we asked for, right? Because again, the screen is not a square. The screen is a rectangle, so the computation will be different for each. So we feed it a rectangle and say, okay, tell me for this width of a room that I want, what is the width of, what is the distance for the camera to match it? For this height of the room, what is the height off the ground of the camera to match it, right? In both cases, we get a height off the ground. We're going to end up with two camera distances, right? Two heights of the camera off the ground. And it's kind of hard to, I'm using height in two different ways here, so I guess I should just say, for an x range and a y range, what is the z displacement of the camera off of that plane that will give me what I want, right? I'm going to end up with two different displacement values, right? So I'm going to have two different camera z's. So all I need to do is say, well, okay, what I'm trying to do is fit the whole room. So I just want to take whichever one is greater, because whichever one is greater will encompass the more difficult thing to encompass, right? You can imagine a room that was like very oblong, right? So this width is very small and this height is very big, right? Well, the distance for the camera to encompass this room is going to be something like that, right? So obviously the value that they get back from solving this is going to say, well, to fit the width you don't have to be very high, but to fit the height you have to be very high. Obviously we want to fit the height in the case where we want to fit the whole room. Now, so that's max, right? That's we would take the maximum of the two. But we might also want to take, again, for gameplay purposes, maybe we want to take the minimum of the two, because the other way we could look at this problem is by saying if there's a room that's really oblong like that, what I want to do is see a whole, I want to fill the screen with the room, right? So what I want to do is take whichever dimension fits the tightest and take that, and that would be min. And then that's if we wanted to do screen scrolling, because then we would know we'd fit one axis exactly and we'd scroll the other axis, right? So hopefully that makes some sense. Okay. So how would we actually do that if we want to do that? And I guess we don't need the game running at the moment. What would we actually do there? Well, if you remember, if you go back to render group, you go down to the bottom, and if you remember, there's a bunch of stuff that we were doing here that already sort of involved all these things, right? So you can see a bunch of this stuff down at the bottom of the function here, and we have, like, for example, this thing called unproject, where you give it an object transform and pixels xy, which is basically like the pixel position of the thing that you want unproject, right? And it undoes the projection, pushes it forward, right? And so what you can see here is if we have an orthographic transform, well, we don't care about that kind of thing because we're doing a perspective transform for our geometry. So the orthographic transform is really not relevant. That's for like UI and stuff. But if you take a look at this other one here, you can see, oh, okay, so we kind of know how to unproject stuff off the screen. If we take a screen location and we subtract whatever the center of the screen is, right, then we multiply it by our meters to pixels to get it into world space. So it's coming in pixels, and we want to multiply it by we have meters to pixels, and we want pixels to meters, so we're inverting it, right? Then we go ahead and take the distance above the target minus however far away the thing is, and we divide that by our focal length. We then multiply by, we take that ratio, which again is that similar triangle ratio I was just talking about, and we multiply by a to get, which is the meters value we looked at there, to get where we would be in world space, right? That pretty much tells us exactly the equations we were looking for before, right? So this right here is that ratio, right? The transform distance above target minus loss of p, that's the distance, right? And then this focal length here that we divide by, that's the thing that actually converts it to the ratio that tells us about the similar triangles, right? So once we have a value that's in meters, it's pretty trivial for us to get it back, right? So if we wanted to, we could go ahead and say here, all right, let's create something that will tell us this information that we want to know. If I am going to pass in some kind of a rectangle, right? So this is exactly the function I was just talking about. If I say I want to, get distances, camera distance for rectangle, or maybe like fit camera distance to rectangle or something like that. So if we want to, we can pass in the dimensions of our rectangle and then this information here. So assuming that the object that we're talking about is at this transform and it has this dimension, right? What is the distance that the camera would have to be off of the plane in order to give us what we want, right? And so given that, we pretty much know, like I was saying before, we know that the distance above the target which is there we go. We know that this camera transform, right, which is set for our render group, this camera transform is going to give us the distance above the target that we're looking for. And the object transform offset p.z, that's going to give us the focal length. That plus the focal length of the transform is going to give us that ratio. Now you'll note we don't really need the offset z here, right? It's really just, we could just use essentially the focal length, input the focal length and a z value together, right? Those could be the pieces of information that we actually pass into the routine. But I'll keep it like this for now, just for a second, and we can see what we want to do in a minute, right? So if we compute that ratio, right, what we've got here is this is, let's expand it out a little bit here, right? This is our z value. In fact, I can actually even just name them what they were here. If you take a look at, no. Here we go. If you take a look at this here, right, we've got our dv and our wv, right? So those are the focal length. So it's kind of tough to describe focal length as well because it's sort of it's sort of an odd concept, right? But the focal length of the lens we talked about before is, if you imagine this were an actual camera, the image plane of the camera is sort of back behind the camera lens, right? Here's the lens. And the focal length is where that image, the focal length of the lens is where it how far back from the lens it takes to sort of converge the light, right? I can get a better diagram for this. I'm sure. Here you go. So when the lens, when you have, if you imagine a curved lens here, right, the focal length of the lens is from that lens shape. It's how far it takes to converge the light to a point, right? So this is kind of a misleading way to draw this. I mean, really, it's like that sort of a thing, right? Because the lens is not a point, right? The lens is an actual shape. So anyway, the focal length is that distance there, right? And it's basically saying from the imaginary lens back to the point where all the light converges. And then from that point, right, the light, and it's not, when I said I wanted a better diagram, I guess this isn't really the diagram I wanted. Because I wanted to show the light converging and then diverging again. Basically, like, the focal length is here, and then this sort of reversal of the light as it passes through that one point, it then has an image plane or something like the film of the camera or whatever, the CCD of a digital camera, where the light is getting sort of placed, right, where the light is getting collected. And we don't simulate any of that in our pipeline or anything like that. Some advanced 3D pipelines will try to simulate things for this, right? But for our purposes, right, it's just this value here, right? And so in order for us to know what we are expecting this value to be, right, here is the focal length, right? So that's the focal length. But this value right here, we don't actually know what that is, right? That's not in this equation here, right? And you can kind of see that it's not being, it's not represented here, right? So what is that actual, what is that actual value? Well, we do have that value. It's just not it's not stored in there. For the camera transform, where we have meters to pixels, screen center, focal length, distance above target, and all that stuff, right? What we actually needed was the monitor half-dim in meters, right? The monitor half-dim in meters is the thing that tells us how wide the screen actually is at that focal length, right? So for that distance away, we know that the monitor half-dim in meters is actually how big the monitor itself will be. And that wasn't relevant in our unproject because nobody in the unproject cares how big the monitor is, right? That's just not relevant because, I mean, in some sense they do, but it's baked into meters to pixels, right? Meters to pixels already captures that for the purposes of unproject, which doesn't care what the actual extents of the monitor are in any particular way, right? So now if we want to compute this ratio, we know we've got the focal length, which is that distance, and we know that we've got the monitor half-dim in meters, which is the either the width or the height of the monitor, depending on which one we want, but it's half of it, right? So at that point, we can easily just go, OK, we know we can, I don't know why I've got this as a z here. We know we can compute exactly this triangle relation by using this as the monitor half-dim in meters, this as the focal length, right? And then we can solve for this using this input, which is the dim, right? Because it's only one leg we don't know. Excuse me. All right. So let's just continue down this road a little bit. So when, in fact, what we could do here is say fit camera distance instead of to rectangle. I think what I might do is make two of these, right? Fit camera distance to to dimension, right? And what fit camera distance to dimension would be, would say, all right, for the monitor half-dim in meters and a dimension in meters, and then the focal length. For those three values, that's all I need to know to compute this ratio, right? So all I need to do is say my result is going to be the focal length, right? Which again is this dv here, right? And we solved the equation. There's the dv. Times whatever that dimension is that I was looking for, dimension in meters, divided by whatever that that monitor half-dim was, right? But this, of course, has to be halved as well because we're only looking at half. So we might as well just say half dimension in meters. So that way, if that's what people happen to have, they have it. Otherwise, they can multiply it by 2, right? I mean, divide it by 2 or multiply by 0.5. So that computes our similar triangle for one dimension, right? And it gets us back. You can see the conversion happening pretty directly if you think about the dimensional analysis, right? You've essentially got a focal length. You're trying to solve for another focal length. So you multiply the focal length by the dimension that you're actually looking for, and you divide it by the dimension that you know is the screen dimension, and that's the ratio right there that you're looking at, right? You could view it alternatively more like this, because it makes a little more sense, perhaps, right? Where you say, if I divide these two dimensions by each other, because those are the two things that I know that are in the same space, then I can multiply by the focal length to get out some other focal length that's essentially going to be the distance that I want the camera to be at, right? So since this is all over the monitor half-dim in meters, that's good, because that way we're never going to divide by 0, because we know that the monitor cannot be 0. We should not be getting to this point if it is, right? So we could guard this, but I'm not going to. That's if you like size the window all the way down to 0. I think we just don't want that to be allowed. So what we would do if we allowed sizing of that nature, I think we would just not call the game render loop at all if we detected the monitor size of 0. So anyway, fit camera distance to rectangle. That is going to now want to do this twice. So what that's going to do is say, like, okay, we've got a dimension, or a result rather, which is just 2 calls to this, right? And that's going to call it with all of these same pieces of information, right? And when we do fit camera distance to rectangle, I guess what I'd say is let's just go ahead and do it this way. Let's make our names. Maybe something like that. I don't know. I'm not sure. This is still half dim. I guess they're both the same. Really, honestly, they're the same. So if we go ahead and call this half dim in all cases, and then we just have 2 versions of it. One you can call with a vec2 and one that you don't, and then we just pass it through. So that is a way to just sort of say, okay, we're going to do an x and a y version together here if you want to. That's the same equation. Doesn't matter. It's just doing it with a vector, right? So no big deal there. And so once we have that function, now we should be able to compute the values that we wanted to compute in order to get information about the camera transform. Now, one of the interesting things about the camera transform in this case, again, is it's kind of ad hoc. So we'll probably clean this up a little bit when we do the 3D version of it. But you can see that it's got a distance above target that's inside the camera transform. And so what we kind of want to do here is understand that that's going to get taken into account. So whatever value this gives us back is actually has to be compared against the distance above target. Because it's not like the value we set for the camera doesn't include that. It does. So if we take a look, for example, at world mode, right, and we go in here. And here you can see us starting to deal with the camera stuff. Here's the distance above ground. It's just set to 11, right? And so that distance above ground value is kind of baked into everything. And to be honest, I guess I don't really know why it is set that way. Sorry, distance above target. Because really, that distance above target value seems like the sort of thing that should just be set off the camera offset directly, right? I mean, if you think about it, there's not a whole lot of reason why you would not want that to just be all part of the camera offset, right? So the fact that that distance above target is there at all is kind of weird and doesn't make a whole lot of sense, to be honest, because it just seems like you're just putting a lot of weird stuff in there for no reason, right? I mean, here's the camera transform, right? And this distance above target is really the camera position in Z, essentially. But what you'll notice about that is it doesn't include any other positional information for the camera, which is kind of bizarre, right? Like if you were going to include an offset for the camera inside the camera transform, which of course makes plenty of sense, you would expect it to be a vec3, because you would expect it to be a thing which says, hey, here's a displacement that you apply to everything before you transform it, right? But instead, we only have a Z transform that we apply in there, and why we do that, I have no idea. Because you'll also notice that what we ended up deciding to do here is in the object transform, which is right here, we bake in the camera position to that transform, right? So we're essentially doing that because we don't have any way to not do that, because the camera transform itself isn't allowing us to specify an actual vec3, right? Which doesn't make a whole lot of sense when you get right down to it. And if you take a look at what's happening with that camera PZ there, right, we're using that value out of the camera P, but really it's more appropriate that should have been something that was in the camera transform to begin with, because that's what that actually means. We're now sort of having to pass two things all the time: a camera transform, but then wait, no, really also the camera transform, right? And that's just kind of dumb. It doesn't really make very much sense. So maybe let's take the opportunity here. Oops. Maybe let's take the opportunity there to just correct that oversight, such as it is. And so when we have distance above target, I'm just going to say, let's say that this is the camera P. And so we'll set the camera position in world space in our camera transform, and then that will just apply everywhere, right? And that seems better. So if we just do that, then what we should be able to do is say, OK, whenever we have like distance above target here, whenever we're using that somewhere else, what we want to do is just apply that transform completely, right? It's going to get applied on top of all of the other pieces of information that we have here. You can see that all the rest of this stuff, right, where we have raw xy and all that stuff, and original p plus object transform and all that, stuff. So when we have our raw xy, that's our p xy that's coming in here and being done with the object transform and all that stuff. What we should be able to do is say, oh, all right, take the pxy and add the camera transforms xy to it, right? Well, not add, subtract, right? Because wherever you move the camera, everything's going to center around it. So subtract that away, right? And then when we want distance above target, OK, we can just look at that z value that we have there, right? And then the rest of our stuff just flows normally. There's nothing else that has to happen there, right? Similarly, when we want this piece of information here, right, we have to do the same thing, but we have to do it in reverse. So we've got our camera P here, and we're going to do that again, that same subtraction. So to find the distance from the difference from where the camera is in that case, to finish the unproject. Excuse me. And then we also have to do the exact same thing. When we then figure out what the result is of our unprojection, or rather when we produce our world space piece of information, remember what we were doing is we're doing this displacement and then we're projecting. So now we need to unproject and then do the displacement. So we've done the unprojection here. We then have to go ahead and say, OK, whatever our unprojected xy is, we have to then add the camera transform back in. So in this case, right, we could change this result. Well, I guess because it's got the offset p for the whole thing. When we go ahead and do that on project xy, we can just add into it the transform camera p's xy to like restore that part of the transform, right? So when we say get camera rectangle at target, this is again just doing the same sort of unproject here. And so when that places distance, when that calls camera transform camera above target, we just want to say for the camera p's z value, that's all that piece of information is actually giving us. In this case now, when we call the perspective transform, what we're going to want to do is say, OK, what we actually want to do is pass a whole camera p here. And similarly, although my head is in the way, let's just kind of scroll down there a little bit. When I say distance from target here equals 1.0, we again can just say, well, all right, we have a camera p, and that can be equal to that effectively what the same thing was, right? So now whenever we call perspective and we want to say distance above target, the question is now just where is the actual camera p, right? And so if you look at where the camera p is getting computed, let's find out here in update and render worlds. It should be getting called down here somewhere. Here it is. Here is our world mode camera offset, world transform offset P nonsense, right? All of this stuff now, hopefully, we can sort of bake away and make a little bit cleaner, right? Hold on a second. Okay. So let's see if we can do that. So you can see in this case, when we call simulate, it's not relevant, right? Because simulate doesn't actually... oh, wait, no, it is. So here's our world mode camera offset that's getting passed there, right? And so the goal here is to sort of get rid of that world mode camera offset, right? We want this to look like that. So the world mode camera offset is actually just part of that camera P that's getting set up in the first place, right? So the world mode camera offset, I don't think is actually touched anywhere in here. Yeah, it doesn't look like it is. So I'm just going to go ahead and put it in here for now. There you go. And we'll see. We'll give it a shot. So here in simulate, which is here, it's taken this camera offset. I'm just going to get rid of that, and I'm going to get rid of everywhere we were passing it. So I'm just getting rid of that whole chain of custody there, right, where people were passing that down, which is good, right? We want to simplify that. And then we just need one in here for the, this is for the layered scene rendering. And you can see in here, we actually have a camera offset value, which is what we were using here. And that camera offset value is probably getting applied all the time, right? You can see it getting applied all in here. Rather than rewrite that code, I'll just leave it the way it is at the moment. But you could imagine making this simpler as well to do. We could simplify this potentially in the future by changing the camera situation here to use camera P. And so then all we really have to do is take this entity stuff, which was taken into account before. And if we want to, we can literally just get it out of the render group because it's there. And that should actually be all I think we really need to do. So let's double check. Epically successful. You always got to love staring at a blank screen. So yeah, you'll notice this is why I decided to do this first before trying to do the other thing at the same time, because I had a feeling we were going to have to trace this through a little more carefully. And I suspect that I suspect that blank screen indicates that is the correct assumption. So you can see that we're just using the camera P's Z values here, right? That's all that's really getting done. And oh, right. And so this offset P now is already always going to take that into effect, right? So the offset P of the entity transform no longer has to have that information in it. And that is at least one improvement that was going to cause us problems. But so the camera P getting used, let's see where this is going to get used here. So that camera P getting used to figure out these typical floor height pieces of information, again, that's something that we want to get rid of entirely eventually. So yeah, we're going to have to do something about that at some point. But you know, for now, I think that should have still been working, right? We should still have been able to use the camera P there. That shouldn't have been causing us any problems, I don't think, right? So I'm guessing, and I don't actually know, but all we really need to do is just restore to our offset system the concept that we had a basis of 11 meters before. So this distance above ground is, right, this is not in there anymore. And so I think if we just now say that our base camera offset, because remember, we're setting the camera offset here in add standard room. I think all we have to do is say our standard camera offset now just has to be taken into account when we're creating that camera height piece of information. So instead of just the diff, what we actually want is that base value of 11 plus the diff. And I think that may be it. Famous last words. Of course it's not. Let me just check something here. So you can see that we do have the correct camera placement. What we do not have is the correct camera distance, which is, I guess, perhaps unsurprising. Do not know where our rectangles went, so that's always good, right? This actually doesn't have the debug camera on, and it's going okay. So that's interesting. It's offset just slightly, vertically. All right, so we have a couple of problems here to address. One is that we still got a little bit of bugginess going on there. The other is, of course, since our rooms are not the right size, when we create that room collision, because the room collision volumes are always marked as the same size, we have this problem that where we start our entity is not actually in a room, right? And that's a bug. So that's a problem, obviously, but we can deal with that in a second. Our more pressing problem is we don't seem to have that value correct, and also our rectangles are not drawing correctly, which makes me think that we've done something incorrect with our the way our rectangles are working. And I'm not sure why that is the case. So we'll have to kind of think about why that is. Let's see here. So that looks relatively okay. So let me just go ahead here and just double check something. So here's me walking to the left. And you can see as soon as I get into the room boundary, we end up centering ourselves horizontally correctly, but vertically not, which is pretty interesting, right? And I'm not sure exactly what the reasoning is for that, because it seems like that should not be the case. And I'm not sure why that is the case. So since the camera P is getting applied here by the, every time something gets transformed, we subtract away whatever the camera P's location is there. Excuse me. We have to figure out sort of what exactly, let's see. We have to figure out what exactly is happening in terms of setting that that is bogus. So I'm passing the offset from the world mode here. And that camera offset, again, should just be, it shouldn't be anything special because it should be exactly the same things that we were passing before with no real change there, because now we're passing a height that's a delta off of the height that we were expecting, and so that seems totally reasonable. I'm sorry, we're passing in a height there that includes the value that we were previously setting to and the delta, so that should be the same. So the only difference here is rather than baking that into our drawing stuff, I guess well, there's a couple of places here that I suppose that we might have used this, so I suppose I should double check what those are. So if I look at camera.offsetP and where that's getting used, right, which is, I'm sorry, just camera.offset. Yeah, so it looks like I'm still doing that in a couple of places here that probably don't want to be done. Now this one for the world transform here, this is only done for doing those outlines of like the world rectangles and stuff. So that shouldn't have affected anything. But at least that simplifies that code a little bit. For update and render particle systems, the world mode camera offset shouldn't actually need to be applied at all anymore. So if I take a look at the particle systems code in update and render particle systems, and we look at that camera P, in theory, we should not have to do this anymore. Now, floor Z, on the other hand, we would have to do. And that's, again, part of that sort of nastiness that we were trying to do, were to keep everything sorted into layers and that sort of stuff. But this offset P for the transform now is already is getting remembered properly, and passed through properly in the camera itself. So I believe that part to be unnecessary now. So let's double check here. Yeah, but we're not getting those particles properly, so we still have something wrong. You can see kind of, there's like particles over there, but those are incorrect. And we're still not getting our floors correctly. And so I think most of this probably just has to do with the Z sorting for floor information, right? And to be completely honest with you, I don't super remember how we did this weird floor stuff. One of the reasons I wanted to move to the 3D thing was specifically because the floor Z stuff is just really weird, right? Okay, so you can see what's going on here. It looks like the floor Z stuff gets combined with distance above target. So basically, now that the camera Z includes that piece of information, yeah, not a smart way to do this. That's going to be wrong. You know what I'm saying? Because the floor Z is not the correct piece of information. It doesn't need to take this into account, right? So the fact that that camera PZ is getting used there at all is actually wrong as well, because that's getting accounted for again after the transform. So really, this doesn't need the camera P anymore. Pretty much at all. And let's just remove that entirely from the pipeline. There you go. And so now, in theory, yeah, there we go. So now we have restored our particles back because we fixed that double Z displacement that was happening there. And again, that's felt good because like a lot of that stuff was just too hacky, and it was, you know, it's stuff that's in there because we were sort of trying to figure out how to handle the like sort of pseudo having to render 3D stuff in 2D thing that I never was really happy with, because it just creates all weird problems like that where you're like, okay, these are weird coordinates and having to deal with all this stuff. It just doesn't seem to make a whole lot of sense, which is why I wanted to move away from it. Okay, so the particles are restored, and that's good. Now let's take a look at the entities. And again, let me see what we actually use that camera P for. So when we're looking at camera relative ground Z here, I think that still needs to take that into account. Obviously, it does. But if you take a look at what that was doing, this again doesn't include that displacement. Or I should say, previously, that was not including the displacement, right, of 11. It was not including that any of those displacements, right? So I don't really know what to say about this because, you know, I think in some sense this is just totally wrong. This has to be grounded. This has to be a delta value off of something, right? Essentially, this has to be that, right, in order to get back the value we were doing, which is how far away are we from our baseline value, which is kind of nuts, right? Which is, again, why I say this is not a particularly good way to do this. And if you look at the camera relative ground Z, I think the same thing applies here, right? If you were going to subtract this, again, you have to remove that default value because this code was written assuming that it was just a displacement from normal, which again is not correct, right? So yeah, so not great, and again, not really what we want to have happen there, but there you go, right? So now things are at least getting a little more sane, but they're still not as sane as they should be, right? And I think, again, this is why I would like to move to 3D to sort of prevent having that sort of constant annoyance of having that problem. But at least getting back to a more saner approach, right? And I don't know how far we need to go down that rabbit hole of actually cleaning this out, because I think what we really want to do is just convert to a nice, clean 3D version of it, and then we don't have to worry about any of these because we won't constantly be like, wait, okay, how do we want to handle floors versus this or whatever, right? So yeah, so that's all pretty nasty and probably should get will just get cleaned out when we go to straight 3D. Now the problem here again though is we still have a couple other things, even just for baseline, to make this work correctly that we would want to do. So for example, what we would want to do first is make sure that our rooms actually have the sizes that our rooms should have. That's like obviously something we would like to fix. So let's go to add standard room here and just see what we can do about fixing that fact. So what we can do for now, again, because we don't really have a strong opinion on this either way since we haven't really done world gen yet, what we can do for now is just create entity collision volume groups as we go, right? So instead of doing room collision here, we can just make one of those every time. Yeah. Where we make a simple grounded collision volume for every room based on how big the room actually is, right? So we knew here that we have how many tiles we have. We know that information because we know the radius. So it's just 2 times radius x plus 1 and 2 times radius y plus 1. And that gives us the information that we want. So then we have the tile side in meters, which we don't actually know at the moment, but we could easily have someone tell us, right? And in some set, chunk position from tile position needs to know that as well. So that's going to be in the world struct that we can grab out, right? So we can go ahead and say, all right, whatever the tile side is in meters, there you go. Wait. Chunk position from tile position. Chunk position from tile position needs to know that piece of information, right? Oh, it's just fantastic. I guess we just sort of said, well, here's that value. Pretty fancy, huh? Yeah, so that's pretty ugly. So what we probably want to do there is to at least make this a value that we know globally for the time being. And probably we want, since that's not going to be constant, we'll probably want something a little more sane pretty soon in the world creation stuff that makes that, less of a thing. I would really like it if my head was not in the way, so I think I'm going to move over here. All right. So basically what we're substituting for at the moment is, we sort of have this hacky world generated stuff because we need some world gen to test. But what we really want is some utilities for building worlds, and when we're building those worlds in a local region, we're going to presumably want to set a tile size for talking about tiles. But our game isn't hard-coded to tiles at all. It can be nice and variable, and we probably want to take advantage of that. So what we're going to need to do is sort of have ways of constructing, okay, this area is a grid, this area is not a grid, here's how to work it. So we really are just sort of compensating for that at the moment. And so I don't think there's any need to try and look at that now. So I just want that as a global, so no one's going to even think about it or care about it. And it doesn't have to be something that anyone even is thinking about temporarily. And then when we go to actually make something a little more creative there for the world stuff, that's the better part to start addressing that, right? So I'm going to go ahead and do it this way here, where we have a, let's see, where we have one of these per room. that's got to be moved up. Okay. Okay. So I think we're good. And now at least our rooms correctly have their bounds. And you can now kind of see that being placed in here properly. You can see that the bound properly encompasses the actual room, which previously it didn't, right? And so now we get we get correct movement through. And we don't have that weird like in-between zone anymore. You're always either in a room or you're not. And that's exactly what we wanted. Now, one thing that you'll notice this is still happening buggily, though, is the screen is kind of offset from the bottom. Like a room is not centered in the view. It's skewed in Y. You see what I'm saying? So the offset of our view in Y is erroneous. And so I think what we want to do, because we still have about 20 minutes left or so, 25 minutes left on stream, I'd like to just get to the bottom of that. Again, not because that code will actually stick around necessarily, because as we go through and do the cleaning up of the 3D-ness of it all, I feel like that will go away. But at least at the moment, I would just like to know where the source of that bug is, just to make the code as correct as possible going into the 3D cleanup pass, so we're not spending our time tracking down bugs that might be in something that had nothing to do with the change to 3D. So I'd like to have that, if that makes sense, even though the code is not super important at this point, right? So let's go ahead and make that happen. Let's first go ahead and ask ourselves the question of how are we centering that camera, right? What is that actual piece of information that we're using? And I believe the way that we're doing that currently, if you go ahead and look at SimRegion, is, update camera for entity movement is going to take whatever the in-room value is there, and it's going to use that to compute the room relative p. So you can see here we've got the room relative p and the test entity p there, right? So the room relative p that it computes for figuring out where it thinks the player is going to be based off of that test entity p. However, the test entity the room CAMP, which is where we think the camera is for this room in general, is the test entity p location as well. If we take a look at what happens here, however, the camera offset itself is not initialized to be the difference between the test entity's position and the actual, how should I phrase this? So the offset of the camera, because remember, everything's in local space to our sim region. So everything's been mapped into a thing that's around the sim region origin. But the sim region origin is set arbitrarily, right? I mean, we know what it's set to because we can go look. But in order for this code to be technically correct, it shouldn't depend on what the sim origin was set to. The sim origin should be able to be set to anything, and this code should still set the camera in the correct position. So what we want to say here is the camera offset, right? Where we believe the camera to be for purposes of rendering. That should be based on the difference between wherever the simulation region is, which is where all the positions are relative to. The camera should be recorded in that space, right? So now, rather than doing things the way we were doing them before, this camera offset z is not the only thing that should actually be getting updated here, right? What should actually be getting updated is the entire entity, the camera's entire placement itself. Right? So whatever room we're in, we should center around that room. That's where the camera should be, if that makes sense. So whenever we're whenever we're in a room, our camera center should always be wherever that room is. Now, at the moment, our sim region, I believe anyway, is always set up to have itself centered around there anyway. So I don't think there's actually any difference between the code I just wrote executing now and the code that as it was executing before. But see, there's a little bit of flashing at that transition point. I'm not sure why. Hold on one second. I want to take a look at that. Anyway, what I was going to say before was, but I believe that's still more correct, right? So, simulation, that's what I want. So it's just at the changeover point. I'm assuming that has something to do with the fact that it's not in any room at all. Maybe? So I'm not sure what happens in that one case, because if we're not in any room at all, then in theory we should not be modifying the camera offset. And so I don't think there should actually be any changes here to that. Now that may not be true. Someone else may be setting that camera offset somewhere, because there was no rule in the code base about when you could set the camera offset to something. So I don't actually know that that's true, but I didn't think that there was anything happening there in particular. Let me take a quick look and see who actually touches this, just so I can eliminate that from the set of possibilities. So that's nice and clean. I mean, nobody touches that thing except these two routines, right? So that's good. I mean, that's where we want to be. But we still have the bug. So we're not out of the woods yet just because the code is getting cleaner. So what I would like to do is I would like some information to try and figure out whether or not the case that I'm seeing does coincide with what I suspect. So all I want to do here is create an assertion. In fact, I can create this assertion, I guess, without the if statement. I can just say, I want to create an assertion so it'll fire when we are not in a room, right? And then I can see whether that assertion appears to fire at the exact time when we were seeing the flash or whether it's not. And that will help me tell if those are correlated. Okay, it doesn't actually seem to be doing it right now, which is odd. Let me drop the time step down. So I'm definitely seeing the flash there. Hmm. So I guess what I would say is this may just be an artifact of the fact that this particular piece of code here is just based on a room delta, which doesn't really have anything to do with anything. Right? Because if you take a look at what's happening here, the room delta is just whatever the size of the room is. But that's not actually correct, because if the other room is a different size from this room, then the room delta isn't properly half what it should be. Although if we only are going halfway, then the other room should go the other halfway when we pan. So to come to think of it, I don't know, that's not actually a good enough reason, really. It seems like that's actually still should be somewhat accurate. So I don't know what the problem is here with this offset. That's still a good question. I guess what I would say is maybe let's go ahead and just not do this offset. Here's a thought for you. So that changeover would coincide with the time when the sim region moves from one block to the next block, because we're changing the camera's base location here, right? So what I could totally believe is happening is this offset will be used on the next pass, right? So if we set it to the new room, we are going to compute a camera P which is erroneous, because it's going to be working off of the I'm sorry, we're going to compute an offset that's erroneous, because it's going to be working off of the old location of the sim region rather than the new one. Does that make sense? So what we need to do here is, when we detect that we've moved from one room to the other, or rather whatever room that we're actually in, rather than using a comparison with the room apron here, what we actually need to do is first compute the what we actually need to do here is compute the offset that we would have had before we changed rooms, or not touch it at all, I think. Because let's just go back over exactly how this is flowing through the pipeline here, right? Because here's update camera for entity movement, right? So here's update camera for entity movement. It's going to get called at the end, and it's going to get called, it's going to do this operation after everything's already been drawn for this frame. So the next frame is going to use whatever, it's like one frame behind, right? Is one way to think about it, which we may not like, right? We may want this to try and be one frame, to not be one frame behind, but to be synchronized. But, you know, for the sake of an argument, okay, let's just take a look at what's going to happen in the current case. So we're going to come through here, and we're going to compute a offset and a location for the sim region, and those are going to be used for next time, right? So when we do this computation, we have to be careful that we're not doing anything in a space that has to do with where the sim region is now, because the offset is going to get used for a different location of the sim region, right? So I just want to verify, or I want to take a look to see, to make sure that we're never that we're not doing that at all, right? So for example, here's the camera offset, and here's the in-room P, okay? That in-room P is wrong as far as the next sim region is concerned, right? Because the next sim region is actually going to be the new location of the origin. So when the sim region changes over, there is no way to avoid the fact that this is going to actually be incorrect, sadly, right? So in some sense, me trying to make this code better, right, by saying, oh, let's take the offset into account, actually made it worse, Like, this is probably what's causing that displacement, because at that changeover point, it's wrong, if that makes sense. So let me go do it one more time here. And again, I'll slow that percentage way down so we can see it easily. So there's that scroll, right? And let's go ahead and put it back in. What happened? Huh. Ah. I wonder when we did our update of the GUIDs if we forgot to do, because you notice our loop live code editing had a problem when we did our update of the GUIDs to handle the GCC compat, if we don't copy them anymore, if that makes sense. Hold on a second, I want to take a look at that. So it looks like we do copy both of these pieces of information when we do get element from event here. So I'm not sure that that should have introduced any particularly onerous stuff. Let me take a look at that. And you can see that the bug is back, right? So I think that we can say that this is in fact the culprit. Unfortunately, it does look like that's a pretty transient bug because I can't seem to get it to come back. But yeah, so you can see that that problem would persist there. So I guess we just kind of have to say that, hey, that camera offset always has to be assumed to be the center of the sim region. So maybe I'll just document that, and we'll leave it like that for now. Okay. So I'm not sure that there's anything else to look at here other than that displacement now. And we know that the sim region is properly being created at the camera center. So I'm not super sure why we're getting that displacement, which looks like the centering is wrong for what the 0, 0 value is, but I'm not 100% sure. So I just want to take a quick look at that to see what the status is there. So let's go ahead and zoom in here, right? We got to have a better, I don't know why that's so, our delta code is so unstable there. It's like rounding error, basically, right? That it flips between. Anyway, if you take a look at where that's zooming in on, it's definitely, you know, it seems to be zooming into the center point just fine. It just doesn't seem like the room is centered on that center point, if that makes sense. Or rather, the camera is centered on the room center point. And I'm not sure why that would be. That's a good question. Because if everything is relative to those coordinates, you would think that it would have to be the case that you would not have any kind of displacement of a tile in that direction. And since we know the bounds of the room are what the bounds of the room are, right? We should know where the center of the room is as well, and we should know that that's in the correct location, right? So I'm not 100% certain why we sort of are having that particular issue. I have to think about what possible causes there could be for that, and why we would not be getting that sort of centering. You know, it probably is because the sim region isn't sized to the room. That could be one reason. So let's take a look here. So when we grab a sim region here, you can see the sim bounds gets the standard room dimension, right? And so what's going to happen there is, you know, it is going to be centered about the same place, but it's going to be sized differently. I don't know why that would cause any problems, though. It doesn't seem like it should. But maybe there's something subtle there that I'm not appreciating that is why that would be the case, right? So we have to think about that a little. I don't know why that's still there, because nobody uses it. Just a red herring at this point. So yeah, get standard camera params. We've got our screen bounds there. And that's just setting the Z. So it seems to me that since everything's centered around the sim region center, that really shouldn't cause a problem. The fact that the simulation region is not sized to the room may be something that we want to fix for other reasons, but I don't think it's a reason, I don't think it has any particular effect on the centering that I can think of, at least not at the moment. And if we take a look at the frame-to-frame delta here, that's only affecting the particle system, so that wouldn't have any effect. So yeah, I can't see a lot of reason why we would be getting a displacement there. And I would expect the center of the simulation region to be in the center. I guess the most logical thing to do now would be to try to draw something that's where we think the sim center actually is, right? So if I went ahead and pushed a rect outline on here, I'm going to offset these a little bit. Screen bounds, sim bounds, and sim region bounds there. I'm not sure what the difference is between those two values at the moment, actually, though, to be fair. But let's take a look. So it's kind of as I expected there. Like, you can see that the simulation region is lined up in X with the screen, but it's not lined up in Y. Not with the screen, with the room. And so that's an interesting question as to why this is the center tile. We would expect it to be in the center of this white rectangle, and it isn't. So my hunch as to what was happening is correct, but you know, my hunch as to why it was happening is not only just not correct, but rather we would say non-existent. I don't have a hunch as to why that's happening. And so I feel like we need to try to make a determination about why the sim region, why the sim region doesn't seem to be centered in the way that we would expect. So how do we compute the sim region center to begin with, right? And let's just take a look at that. So when we create the sim region inside simulate, I assume, or rather inside begin sim, we're using the camera.p for that. right? And that camera.p is going to be set inside, at least after the first frame, is going to be set inside here. And it's going to be set by mapping into chunk space whatever the root cam's position is relative to whatever the origin position is of the sim region at that time. So whatever the sim region was, which is this, we're just going to say, pretend we have an offset of that, which is whatever the entity thinks it's at. Map that into chunk space, and that's going to be the position that we're going to use as our center. And that seems pretty valid, right? That's going to or should be computing a point that has that information in it, that information that we expect. And I don't know why we would get a problem with that unless we are incorrectly applying that when we actually do our unmap, right? So let's take a look at how we're doing our unmap. So here's begin sim, or I guess begin world change, rather. So here's begin world change. And you can kind of see us doing our thing here. When we go through and try to compute where things are, we do subtractions of the chunk position from the origin. And as far as I know, that chunk delta should include the origin's offset, right? Which is whatever gets passed in here, which should include the micro offset, not just for the chunk. Let's make sure it does, for starters. And it looks like it very, clearly does. You can see it using A offset and B offset there, where it subtracts the two. So that should be, that should be correct for all intents and purposes. So that chunk delta that we get here, where we subtract the sim region's origin from the chunk position, that should give us that displacement out to that chunk. And then when we're taking entities out, right, we're just putting that chunk delta in there. So that seems like that should be correct. And I'll go ahead and we'll run a few times here. And I'll go ahead and look just to see what we're actually getting for those values. So first of all, here's the sim region's origin value. And you can see that there is an offset in there. And so then when we come through here and we do our, let's take a look at the chunk that actually has something in it. So there's our chunk delta that we've computed, like so. And what we should be able to see there, I guess what I'd rather do is verify that it's actually using those values, I guess. So here we go. So let's take a look at our A and our B. And you can see, as you'd expect, the chunk part doesn't have an offset. That's what we want. And the other one does have an offset. And they are getting respected. So that computation appears to be correct. So I do know why the origin is not getting set properly in that regard, right? So that's a good question. So let's take a look at how we're updating our camera. So there it is. And we come down here and we're taking a look at the entities, and we find whatever the room entity is. And let's just take a look at what the room entity's position is. It's 0, as we would have expected. So the room entity is right in the middle, right? Supposedly, of this thing. Now, that doesn't really make any sense, because we're sort of saying that, well, if it was right in the middle, then we would have expected the room's boundaries to be centered with respect to the sim region. They should be roughly about the same, right? But at the moment, they aren't. And you can see that just by looking at the fact that that white rectangle is directly centered, but the room rectangle, which is this yellow one here, is not. So that's a bit of an issue. I'll also point out, though, that the screen bounds are not quite centered either. which also doesn't make a whole lot of sense, right? So I feel like we have a couple remaining issues there. Let me go ahead and reduce the displacement that these are feeling. So there we go. So that just turned out that was just an offset issue, so that's fine. So what's interesting about that, because this is actually very relevant. So when we offset things in Z, they get shifted upwards, it looks like. And that, of course, makes a fair bit of sense because I think that's exactly what we said should happen, right? We specifically said that things should get offset in Y when they get higher, right? That was our whole thing with having the two transforms. And so you can see that we displace the Y with the ortho from Z height off floor, right? So I suspect the reason we aren't getting the centering that we want to get there, it's because our height off floor computation, right, is giving us a bogus value for that. Because now the distance above target for the floor Z, right, this distance above target value is including the whole displacement rather than just the relative displacement, and then you end up with extra displacement there. So I guess what I would say is I'm willing to say, OK, I'm not going to fix that one. I'm going to leave it the way it is, because I believe when we go to 3D here, that will take care of itself, because then we won't have this dual notion of things that happen. We'll only just have the 3D working as it should work, right? And then I think we'll be more OK. So I'm going to go ahead and go to the Q&A on that note. And take any questions that people have. Canucles, hi, for how long is this bliss of weekend episodes going to continue? Got any news in the making for us? Yeah, I actually probably will just keep doing it this way. I like the weekend streams, and I don't have very much ability at the moment to fit week-night streams into my schedule. So I think it will just be this way probably indefinitely. I'm glad you call it the bliss of weekend episodes. That makes it sound like you like it, which is good. I'm sure for any stream time change, there are some people for whom it's better and some people for whom it's worse. But yeah. Oh, Canucles, I did not realize you were asking if there were any additional news besides the weekend episodes. No, I don't have any news at the moment, no. A bit off topic, but why do you use your headphone mic rather than the nice studio mic you have on the Jeff and Casey show? Well, actually, there's a couple of reasons, but one of the main ones is just I don't really have a good way to put that mic in here somewhere where I could talk into it that wouldn't pick up the machine noise like really dramatically, because it wouldn't be on a headset. It'd be out kind of sitting on the table where it would get a lot of noise. And also, I don't really, I can't have it in some place. That mic is supposed to be like right close to your head here. If I was to try and put an aperture that would make that happen, I wouldn't be able to really work that effectively. So, I probably could try to use a better microphone in that way, but I would have to like buy a bunch of stuff to kind of try and mount it in a way that would still let me type and like not, yeah, it would be bad. So let's go. The camera doesn't seem to be centered perfectly, working as intended. Yeah, that's what I was just talking about. I don't know if maybe you just came to the stream, but that's what I was just saying is the reason is because of the Y offset, which we're going to remove. So I'm not going to touch it at the moment. And in terms of testing the theory by just removing that transform, yeah, we can do that, although it would probably have some other side effects. If we change the Y offset, that's that line of code there, and then you can kind of see everything is centered properly, right? So now it's centered the way you would expect. So it's just that Y displacement, which, like I said, I decided I'm going to change the way that works. Started following the series on YouTube and have made it to episode 4. Loving it so far. When I try to build solution in Visual Studio, I'm able to do so unless I put the pound defines and type test into every file. Is this a Visual Studio thing or am I doing it wrong? Sorry for going way back. So you are not doing it wrong in the sense that there's something wrong with what you're doing. You're just not doing it the same way I did it, and that's probably why you're getting that problem. What happens is in Visual Studio, so by default, if you use this Solution Explorer thing and you add CPP files to it, right, and you let Visual Studio do the build, each CPP file is passed to the compiler separately, right? And so because each CPP file is passed separately, anything that might be a .h file or a .cpp file or anything that needs to be used cross-file has to be redefined. That's why we have H files technically when going back to the old days when that's how you always did it, is passing everything separately. That's why you had to have H files, and you furthermore had to like define everything. Like every time you made a function that would be called from one file to another file, you had to into the H file put that definition so the compiler would know that it was something that was available to be called, right? The reason we don't have to do any of that stuff on Handmade Hero is because I don't use the IDE to build. I use a batch file, and this is the batch file. And what it does, right, is it just builds the one file, and all the files are included in that file. So if you look at handmade.cpp, you can see that it includes all of the CPP files in it, right? So what that does is it just makes one giant file that has all the code in it, and it just compiles that one file. Now, if you try to do that in Visual Studio in the naive way, where you've got this file, handmade.cpp, in there, but you also added all the other files in there because, hey, they're the files and you thought you would want them in there, which makes sense. Now it's going to try to compile the Handmade one, which will compile properly because it includes everything. But it'll also try to compile all the other files individually, even though it doesn't need to and isn't supposed to do that, because it just thinks anything that you listed in here is supposed to be compiled as source code, right? So what you have to do if you're going to compile inside Visual Studio is either only add handmade.cpp, and win32handmade.cpp as two separate projects with two separate CPP files, and that's it. So it'll only try to build those. Or you can add everything you want, but then you have to customize your build in Visual Studio using like the build stuff. There's like a whole, I don't even know, like this whole system thing. If this were a real project and not just an executable, it would have a whole bunch of settings here. You'd have to set all those settings correctly. And I believe people have worked that out on the Handmade Network forums. You can go and see how people have done that. And so you don't have to try and figure that out yourself. If you are new to Visual Studio and don't necessarily know how to sort of massage it into the correct configuration to make that work. There's folks who have definitely done this on Handmade Network. I just don't actually know exactly where. New to Visual Studio and don't necessarily know. Oh no, it's me talking to me. No, just stop. Okay. So if you search in here like Visual Studio, I think there's probably, let's see. So I think this is handled in here, kind of, right? You can sort of see, yeah, you can kind of see people working it out. I'm not sure which one of these is definitive because I don't use Visual Studio in this manner, so I don't even have an opinion about it one way or the other. But that's kind of what's available for going down that route, if you will. Does that make sense? And yeah, it looks like, it looks like probably there's different ways to make things work better. And like if you want live code reloading to work, for example, you probably have to do a lot more work setting up Visual Studio than if you just want it to build, right? Because in order to get the live code editing to work, you have to build the DLL and do the thing where we change the name of the PDB, and there's all this other stuff that we do to make the loop live code editing work in the batch file, and Visual Studio would have to be set up to do the right stuff for that as well. So there's probably like degrees of compliance you can achieve with Visual Studio, and there's probably different amounts of work involved in them. But people have sort of posted that there, and so you can go ahead and use that as a resource if you're having trouble. Looks like that's it for questions, which is good because the stream just ended. All right, let's close things down. All right, so before I close things down again, I just wanted to re-mention some stuff we talked about. No, don't do it. Don't do it. Okay, there we go. I was almost going to have me talk to me again. I just wanted to mention again, if you are interested in Handmade Network, which is sort of a separate, it's not a Handmade Hero thing actually. It's kind of like a place for projects that people are trying to do programming in sort of a similar, I guess I would just say like attitude towards how we do it on Handmade Hero, where you're caring about the code and trying to sort of focus on learning how the computer works and these sorts of things. So if you're interested in that sort of stuff, you probably have been to Handmade Network before, but previously in order to get a project listed on Handmade Network, it was just sort of you had to email the maintainers and that sort of stuff because the site has only been around for actually a fairly short period of time. And so they were still working on getting all the other features of it going and cleaning it up and working on the layout and all the sorts of things you have to do to run a website, obviously. And so if you, before, if you wanted to be one of the people who maintained a project on there and use their product hosting services and kind of be part of that community, you had to email someone to make that happen, and you have to go dig to find who to email, and it wasn't the kind of thing that was really set up for public consumption. But they've now gotten all their stuff done that they want to get done in terms of allowing projects to be submitted publicly. And so if you are interested in submitting a project to Handmade Network and you'd like to be hosted on there, you can now do that directly. From the Handmade Network site, which is just handmade.network, you just click on projects, and now this submit a project button should be here. You need to have an account on Handmade Network to do it, but obviously that's free and easy to do. You just click register if you don't already have one, and you can register. And then this button, this dialog here, if you are a registered user, which many of you probably already are, we'll just see a submit button there. And so then you can submit your project, and they can take a look at it. And if it's the kind of thing that fits with what they're doing, they can set you up for hosting the project on there. And there's a lot of great projects hosted on there already, so I would highly recommend checking them out. If you haven't, you can see there's 4 entire pages of projects here that are like all over the map in terms of what they cover. So by no means does it have to be something similar in scope or type of project to Handmade Hero, because most of the things on there are totally different sorts of things. The homebrew operating system, a remake of Quake, the drawing package we use, a voxel engine, everything that you can imagine is already sort of on there. And so there's no reason to limit yourself if you are doing a project like this. It doesn't have to be anything like Handmade Hero. It just has to be something where you're concerned about making quality software and wanting to write things with an understanding of how they execute on hardware and stuff like that. Everything is welcome on there as far as I'm aware. So I would check that out. Check out the projects that are on there if you haven't already. And then if you are working on a project that you'd like to see be part of sort of their umbrella, you can go ahead and submit it here. And I believe that the backend that they have basically includes like all the stuff you need for hosting. So you don't need to maintain like a separate GitHub or anything like that. I think they even have like all that stuff just built in. So it's completely like the forums are there, the GitHub sort of equivalent is there, like all that stuff is just kind of there, which is pretty cool, because then you can just have all that stuff taken care of, and you don't have to have your forums in one place, your GitHub in another place, and blah, blah, blah. So I think it'll probably be pretty useful for people who are interested in maintaining projects in this fashion. And even if you host the project externally, obviously there's still ways that you can use it, as far as I can tell, because, for example, Handmade Hero already had all the stuff set up with the GitHub and Sendowl and all that stuff, and it's still on here for the forums and everything, right? Too. So you can also have that stuff taken care of.
How much do you pay for health insurance?
Please, just don't. Twitch really wants me to see some ads, I guess. So yeah, you can use it also if you're just interested in forum and stuff, but you have a project that fits well. You can still probably use it here. And again, like, these are kind of cool features, right? Like, as much as you probably don't want this to watch an advertisement here, if you are a Twitch user, actually anyone who's Amazon Prime won't see ads, right? I'm just not logged in. I wouldn't normally see ads on Twitch. So if you're live, it'll show up when people are browsing your channel, which is a pretty awesome feature. So there's just a lot of neat things that they're doing. And because they care about this from the perspective of people who are making projects like these, it's very likely that the sort of stuff that you're going to want is the sort of stuff that they're working on. So it's also kind of nice in that respect, because it's not geared just towards people who are doing stuff that may be very different from the sorts of stuff you're doing. It's geared more towards the sort of stuff that you probably are interested in if you're the kind of person who likes what we do on Handmade Hero, because that's their focus, right? So check all that out whenever you get a chance. Again, that's who hosts the forums for Handmade Hero anyway. So if you're on handmadehero.org and you click on the forums button, that's already where it's going, right? And so that's just, if you didn't already know, if you click on that Handmade Network part, you get to the broader site, which has a bunch of other projects that are in a similar vein. And a lot of them also have learning resources associated with them, just like Handmade Hero does. So there's quite a few on there. I think at least 3 or 4 that also have streams associated with them where you can watch and learn about how they were developed or how they're being developed. And so if you do like that sort of thing, it's also a good way to find out what's going on there. Some of them also don't necessarily have educational streams, but do have streams. So for example, when Sean Barrett does development on his voxel engine, he does stream the development. Now, it's not necessarily an educational stream per se, because he doesn't necessarily try to teach you what he's doing, but he does record what he's doing, so you can learn from how he's coding just by observing, right? So if you want to see how he's approaching the code and how he's writing the code, you still can do all of that, right, for that voxel engine. So in addition to the ones that have overtly educational streams, which are designed to be more teaching-oriented and have complete explanations and break things down for an intended audience of people who may not understand them at first glance, there are also streams that are happening on there which are, I guess you might call them more expert streams, which are to say that you could still learn from them, you just have to be a little further along. But as long as you can follow along with what Sean's doing, without too much detailed explanation, you can sort of still see how he approaches code, how he goes about like debugging, how he thinks about things. And there is commentary from him from time to time too, so you do get also some of the back process there. So there's kind of an array of streams as well that you could check out on there that might be useful. And so I would recommend spending time exploring it. If you like Handmade Hero, there may be other things on there that would be really useful to complement it. Or to sort of take it into areas that we don't really cover. So if you're looking for more materials, I would highly recommend it. That's it for today. As always, if you're just interested in Handmade Hero, you can always pre-order the game, and it comes with the source code on handmadehero.org. I upload it every night, so it's always fresh, so you can play around with it. We also have that forum site I was talking about, hosted by Handmade Network, which you can check out. And now's a good time to do it. Like I was saying, it's kind of they've sort of kicked up the functionality on the site a notch to a place where I think you're probably going to be really happy checking out what they've got. We also have a Patreon page if you want to support our video series, a schedule bot if you want to know when we're going to be live, and an episode guide maintained via the fabulous Miblo, which has all of our old episodes on it, so you can go back and see what we did and when. It's got nice time-coded entries, so you can jump to things and all that sort of stuff. That's it for today. I will be back here next weekend to do some more programming. Until then, have a good week, and I'll see everyone on the internet. Take it easy, everybody.